Did you hear Konami fired Kojima?
This week, the beginning of next week, we'll talk about lots of kinds of variation. We're going to talk about direct variation. We're going to talk about the opposite of direct variation. If I were in charge, I would call that indirect variation. But it's not. The math people choose to call it inverse variation, but it really just means the opposite of direct. I call it indirect. We're going to talk about some things called combined variation, eventually, and joint variation. But we'll take them slowly, one at a time. First is just direct variation. And those are things that are directly related, or something that's got a direct cause on something else. For instance, and I know there's lots of other factors involved, but for instance, the more I eat, the more I weigh. Directly related to each other. The more I eat, the more I weigh. Some things that are inversely related might be, faster I drive, the less time it takes me to get there. So the direct, if one number goes up, it causes the other number to go up. Or, if one goes down, causes the other to go down. That's direct as well. The less I eat, the less I weigh. There. If one went down, it caused the other one to go down. So if the numbers are going in the same direction, either both up or both down, that's direct. Inverse, which is really 2 days from now, but I just want you to see the what is and what is not. Inverse, as one number goes up, it makes the other one go down. Faster I drive, less time it takes me, unless I get pulled over for a speeding ticket, and then it takes a whole lot longer by the time we get through all that mess. But for the most part, faster I drive, the less time that I get there. Okay? Or the more I exercise, the less I weigh. More went up, less I weigh, that'd be inverse or indirect. Okay? So today is direct only. But there's lots of things that go with that as direct only. And I think that's where we'll start, is what are some of those things. Tell you what, how about one person from each table go get a basket of supplies? One person from each table go get some supplies.
Have you played a new Metal Gear Solid?
Huh?
You played a new Metal Gear Solid game yet?
I do. I like Metal Gear.
You don't like it? Surprisingly fun.
I thought you were very good and great like that. Very good.
You like that? Like that?
What?
Okay, so we're going to be first creating the right side of our page. So we're going to be creating the page 20 first. You can either cut out this box at the top and use it as a heading. You can leave it all together if you want. You can write your own heading at the top of page 20. It says direct variation. When you go to cut out this square, just want you to cut out the outside perimeter edge. So when it's time to cut out the square, do the outermost perimeter. That other piece that says, what is it? If you end up cutting that out and using it, okay, it's mostly a reminder to make sure we talk about what is it when it's time for direct variation. So for the most part, how about you get that square cut out? Cut out the big square. Cut out and around the big square. Do not glue that square down. After you got your big square cut out, you've got to cut on the lines, but don't cut the picture frame apart. You see? See, we've got to have a picture frame out here. You're just going to cut on the diagonals so that we will be able to fold them back. So just cut the diagonal.
How do I do that?
But take your, that's a great idea. Here, look at this.
What?
Instead of, like I just poked my scissors through the center of it, but if you'd fold it, you could just go snip, fold it the other way, and go snip the other way. That's what I did.
Wait, like this?
Yep. And then you're going to put this page in your notebook on the right side, but the only thing you're going to glue down is the outside frame. So just flip it over, take your glue around the outside edge, put it in place, because you're going to want to be able to fold those tabs back. the perimeter.
What page is going on
Yeah.
to?
That's the right side, you always do the right side first.
First, okay.
So that's under page 20. And at some point, again, you need a title at the top of every page. You can either write your own or cut out the one there that says direct variation. But you're going to have some kind of a title.
Good. Ready?
I think it was that job.
And on the board, follow the square, and you are going to lift up the tabs and write the stuff under the tab. You're going to lift up the tabs. I can't exactly lift up the chalkboard to do that. Underneath the equation,
I mean, you could.
write this. Y equals kx. Underneath the tab of equation, lift it up and write y equals kx. Lift up the tab. Oh, I don't care. That's the point. Either, I did it on the paper, but if you want to do it on the underneath side of the tab, that's okay too. That's a good point. Y equals kx. I want you to circle the k and label it that is the constant. When we go to talk about the constant, that's where you're getting that. That k is called the constant. I think that's why they chose a k for constant. Let's go down to the constant flap and write k equals y over x. That k can be found, and you've done this before. I'll come out here to the side, you don't need to write this, but here's where that came from. Is y equals k times x, and we divide both sides by x. Look what we get, k equals y over x. So we're under this tab that said constant, we wrote k equals y over x. Then write yourself a little note that the same constant for all ordered pairs. The same constant for all ordered pairs. Now let's go up to table, and underneath this, right up high, because we're going to fit something underneath it, y equals 2x. Circle the 2. Make it xy table. Let's pick some easy x's, about 2, 4, 6, 8. Now watch what we're going to do to each one of those. I'm going to take every x, multiply it by 2, and it's going to tell me the y. So 2 times 2 turns it into a 4. 4 times 2 turns it into an 8. 6 times 2 turns it into a 12. 8 times 2 turns it into a 16. See how all of those have a multiplier of 2? That's that k value. K can be found by doing y divided by x. Watch, 4 divided by 2, that's 2. 8 divided by 4 is 2. 12 divided by 6 is 2. 16 divided by 8 is 2. So they've all got that same multiplier. That happens in direct variation. What we got? We got one more to look at. Go over to the graph. Make yourself a little XY chart, or an XY graph. I don't care what line you draw, but I need it to go through the origin. I don't care if it has positive or negative slope. It just has to go through the origin. Don't care how steep it is, but it's really important that you go through the origin.
Should we write that?
Yes. Let's even make 0, 0, must, that'll help you later, must go through the origin. So I'll make that note on mine, make sure I tell that group. We better get the what is it at the bottom filled in then. Down at the bottom underneath that, I don't have any room down here, but you can just handwrite it if you want, or you can tape that little header in. What is it in terms of direct variation? What is it? This is a math book definition. Linear equation that goes through where? The origin. Everything we put underneath those slabs, we could find a way to make them go through the origin.
Shouldn't that be a word for knowing?
What's that?
Your full definition.
Like for direct variation, since it's a whole big topic, I thought since it's got its own page, I didn't put it there. I see your point, but if it's worthy enough to have its whole own page, actually it's going to get 2 pages, you know? Because we're going to have a right side and a left side.
Sorry. Just dropping stuff left and right.
You can have headings there wherever you want. Now our next task off of here is eventually we're going to have to get these sorted as to the ones that are direct variation and the ones that are not. And that's going to be our left page. So let's go to our page 19. You should have a title, direct variation, but we're going to have 2 columns. We did this before for function and not a function. Direct variation, not direct variation.
Oh, so we're cutting them out.
Direct variation and not.
Where are we writing that at?
On your left page, make some headings that say direct variation
The whole
and
thing?
not. Right on that left page. I tried to shrink these down. Remember last time we had trouble getting them to fit? Some of them had to overlap a little bit. Don't glue the page down. We got to sort them. They've not been sorted. Don't think the ones on the left are all direct. Oh, no, 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 no. So, you got 13 of them. Cut them out. And then we'll start sorting them. You can trim them down any way you want. You can wait, trim them down later if you think they're going to be too small. You're going to lose them. Got 13 things, don't lose them. Get all 13 cut apart. And you can start sorting them to the best of your knowledge. You're going to need some help with a few of them, I think. 13 of them. Went ahead and numbered them so that we'll be able to check, make sure they're all correct before you glue them down. Start sorting them on your own. Once you got them cut apart, try to start sorting them into the two piles. We will not let you glue them down until they're correct. There's obvious ones. You can go through and sort out the obvious ones and find out ones that are.
Because this, no matter what you do, you're always going to come back to that.
So let's see if we can. So it's this that makes it a no, because it's always y equals kx, in this case k 3/4. You can't have any extras. This keeps it from going to the origin. You know, that has a y intercept. So
you gotta think about it on the chart, okay.
yeah, and so this one, by the time, where'd it go? By the time you put this one in y equals kx form, it doesn't have any plus or minus stuff. So that's how that one ends up being.
Okay.
This, you know, and that's what we'll do with every one of those. We're going to rearrange them into y equals kx.
Okay.
And if there's any extra plus or minus, it's a no, because that keeps it from going to the origin.
Okay. So, makes sense.
No, some of these we might, but we can do them together. We can. I'm going to be using the chalkboard to help with the yeses and nos. What about 13? Direct or not direct?
Not direct.
Why isn't it? Not direct. 12 is not direct. And if you want to make a little note to yourself out by number 12, that K is different every time. So when you look back and you're trying to find an example, you'll have it. The K's changed every single time. The K's changed. I see one more. I think there's one more obvious one, kind of like what we've talked about.
Number 3.
3, you go to the movies and buy 10 tickets for $10.50 each.
Direct.
Why do you think so?
Because it's the same each time.
It's the same each time, yeah. It's going to go up. You buy more tickets, and the multiplier is always going to be 1050. It's number of tickets times 1050 every time. So 3 is a direct. I still think there's another one.
Number 11.
So 11. The more hours Bob plays video games, the worse he scores on his math quiz.
Not direct.
Not direct, yep.
And that's only not direct because we don't know how many hours he's playing, correct?
Well, that's one reason, you're right. But the other one is, as one number's going up, the other one's going down. So this would be a good, in a couple of days when we're doing inverse variation, it would be a good example of inverse variation. And then the rest, we've pretty much got to think about all of them to see if they're doing this. You know what this reminds me of, this y equals kx? Reminds me of y equals mx plus b. But you don't have the plus b. Now let's suppose we were graphing. You graphed a lot. If you go through the origin when you're graphing, what's your value for b? You go through the origin, what will this number be? 0, right? Remember y-intercept, b is your y-intercept. So y equals kx is the same as y equals mx. And remember, direct variation has to go through the origin. But most people don't write the +0 on anything. Nobody writes +0 or -0. So if we can rearrange these into y equals kx, and you don't have any extra stuff, then it's going to be direct variation. Let's just go to the top. Let's go to number 1, everybody. Let's rearrange it. You practiced that for your last test. Negative 3x plus 2y equals 0. What should I do to start getting y by itself? I want to land y equals blah, blah, blah. Add 3x, certainly. Okay, now I've got 2y equals 3x. How do I get the y by itself? Divide by 2. And I've got y equals, I'm going to write this like this though, 3 halves x. Is that direct variation? Does it follow the pattern of y equals kx? What's k? What is the k value? 3 halves. K is 3 halves. So that's a yes. This one, number 1. This was number 1. That turned out to be direct. I was able to rearrange it so that it fit y equals kx. Y equals kx is direct. Let's look at number 2. Let's rearrange it. Number 2. You guys will be the thinkers, I can be the writer, you don't have much room. What shall I do to get the y by itself? This is where I want to land. I can subtract what? 3x. I can do that. Now I have negative y equals negative 3x. How can I get rid of that negative? Divide by negative 1. Then I have y equals negative divided by negative 3x. Did that one turn out to be direct? Okay, number 2 is direct. Number 4. X minus 3y equals 6. Need to get the y by itself. Subtract what? Now I see negative 3y equals 6 minus x. Divided by negative 3. Y equals 6 divided by negative 3 is negative 2. Negative x divided by negative 3 is like a positive x over 3 or 1/3 x.
It's not
Yeah. What makes it not direct? This. You can't have this. If I had this, there'd be k, but you can't have that. So 4 is not direct. You can't have any. Remember it's got to go through the origin? That wouldn't be going through the origin. So 4 is not direct. Can you tell what 5 is going to do? If you rearranged 5, will you have any plus or minus extra stuff? Here's 5. 8x plus 4y equals 12. How do I get y by itself? Subtract 8x. Okay? So 4y equals 12 minus 8x. Divide by 4. Okay? Y is 3 minus 2x. Direct? This keeps it from being, you can't have this extra stuff. The negative's okay. If it just looks like this, k is negative 2, that's okay. But it doesn't look just like that. 5's a no, not direct. How about 6? You can tell by 6. You don't have to do anything.
Direct.
Indirect. Nope, it doesn't work. That -7. -7 ruins it all. 6 is a not direct.
7 is.
7 is a what?
Direct.
7 is not direct. The +5 ruins it all. Got one more. Got the one in the top right corner. You go to the fair and pay $5 admission and $1.50 per ride.
Not direct.
Watch me translate this. Maybe something like this. The total cost, when you go to the fair, total cost is $5 to get in, plus $1.50 for each ride. Indirect. It is not direct. Because of that 5. If you didn't have the $5 to get in, it'd be direct. But it did cost $5 to get in, so that will make it indirect.
Would that also be considered inverse?
Inverse, that's what you're supposed to say is inverse. But I think indirect is a better word.
Okay.
But the math word's inverse.
No, that doesn't make sense.
I keep trying to get all those math books to change it, and they just don't agree that they're going to change them all. So there, now you got those 2 pages, and the day does end in Y. And the days that end in Y. Yeah, homework.
Hey, where's 6 go? I think it's indirect. Direct or not direct?
6? What did I say? 6 is indirect.
So the top chart, you're going to create some of your own examples for direct and indirect. Then you're going to do a little translating where you follow the examples. And it will take you about 10 minutes. Total time is 10 minutes.
Tristan, you alright, man?
Tired.
You're always tired. You must stay up late.
That's not false.
You work?
No.
Why are you staying up late?
Because I feel like it.
Hmm?
Because I felt like it.
You're a late nighter, huh?
Yeah.